Hello and welcome back to Applied Advanced Calculus. My name is Nathaniel Posesorsky and today we are going to be looking at triple integrals. Let's get started. So for triple integrals, it's important to know that we're no longer working with dA, but now we're working with dV. Also, if we're asked to find the volume, it's simply the triple integral of dV. Now we also have different coordinates. We could work in the cylindrical coordinate system, where we replace x by r cos theta, y by r sin theta, and z, well, simply stays the same. Also, our dv is going to be r dz dr d theta. Now, it doesn't always have to be dz. It depends where your shape is oriented. If it's oriented along z, then we put dz. If it's along y, we put dy. We also have a spherical coordinate system where x is going to be equal to p cos theta sine phi. Phi is the angle it makes with the z, and p is the radius of curvature in some cases. And then y is p sine theta sine phi, z is p cos phi, and dv is p squared sine phi dp d phi d theta. It's also important to know that x squared plus y squared plus z squared is equal to p squared. Now generally, if we're not given any information, we know that for a circle, we're always taking theta from 0 to 2 pi. But now for phi, we're going to take it from 0 to pi. If we are told that we are in the first octant, we are going to take phi from 0 to pi over 2. And if we are told that it is a cone, we are going to take phi from 0 to pi over 4. Phi again being the angle with z. Let's look at an example. Suppose S is a solid bounded by plane z equals to 2x, the surface z equals x squared, the xz plane, and y equals to 4. Calculate the triple integral of fxyz dv. Now since we're not told any fxyz, we're going to assume that it's just equal to 1. Also, when you are told the xz plane, that simply means that y is equal to 0. We're given z equals to x squared and z equals to 2x. So if we place them equal to each other, we could find that x is equal to 2. And now we have everything we need to be able to plot them out. So if we're to plot it in 2D with x along the horizontal and z along the vertical, we have our quadratic equation crossing with a linear equation, giving what in the shaded area in red. If you want to see it in 3D, you could in the graph below, or you could always use another method where the paper, or in this case your screen, is y equals to 0, and you extrude it upwards. That means you place your hand on your screen or your paper, and then move your hand towards you, and that's going to be your new y value of y equals to 4. So there's two different ways of seeing it in 3D. You could either draw it, or you could use that method over there. Now we're going to solve the triple integral. So for x, it goes from 0 to 2. From y, it goes from 0 to 4. And for z, it goes from x squared to 2x. If we solve this triple integral, well, we're going to solve it the same way as we solved a double integral. First, we're going to do the inner integral, which it works with dz. Then the other inner integral with y. And then the outer integral with x. So, if we're to take 1, the integral of 1 is simply going to give us z. Then we plug in 2x and then minus x squared. So that gives us the first inner integral. Then if we do that in terms of y for the second integral, we are going to get 2yx minus x squared y. Plug in our 4, we get 8x minus 4x squared. And finally, we solve the last integral to get 8 minus 32 over 3. Let's move on to a second problem. Over here, we are going to use spherical coordinates. It tells you, use spherical coordinates to find the volume of the solid that is bounded by the following equations in the first octant. We said before that the first octant means that phi is between 0 to pi over 2. So that's the first bit of information. Then we're given x squared plus y squared plus z squared equals to 16. If you remember from previous videos, this is the equation for a sphere of radius 4. We are also given y equals to 0, y equals to x, and z equals to 0. If we're to draw this in 2D, we have y equals to x and y equals to 0. And when we plug in z equals to 0, we get x squared plus y squared equals to 16, which is the equation of a circle of radius 4. If we plot all of this into the graph, we get the shaded area that's in red. We could also draw it in 3D, or we could again use the method to extrude it out to better visualize it. Now, the y equals to x, if we're to look at our circle, that simply represents the angle of pi over 4 for our theta. So we know that our theta is going to go from 0 to pi over 4. We were told that it's in the first octant, so phi is from 0 to pi over 2. And the radius is going to go from 0 to 4. We have our limits of integration for p, phi, and theta. We substitute our dv to be p squared sine phi dp d phi d theta. Now we simply just have to calculate the triple integral. So p squared, the integral of that with respect to dp is going to give us p cubed over 3. Plug in your 4, you get 4 cubed over 3 sine phi d theta. Then the integral of sine phi is simply going to give us minus cos phi. Plug in pi over 2 and then minus cos of 0, which is plus cos of 0. The cos of pi over 2 is simply 0. And then cos of 0 is 1. So we're left again with 4 cubed over 3. And then the last integral from 0 to pi over 4 in respect to theta, which gives us a final answer of 4 cubed over 3 times pi over 4. So, I hope this helped you better understand triple integrals. If so, please make sure to leave a like and subscribe, and I'll see you in the next video. Thank you.